Hi ladies and gentlemen, I hope everyone is doing well today. Today we are taking a look at limiting reactants practice. So again, this practice is a tougher one, so I will walk through question 1A and B for you. You can base the other questions 2 and 3A and B off of what I do in 1. Everyone, before I forget, you should make sure you write down this balanced equation. This is the balanced equation you will use in question 2. The balanced equation for question 1 is given to you. Remember, you probably won't have enough room on this paper to do it, so do it on a separate piece of paper. Base all your questions off of what I do here. So I wrote down some information to help us that comes from the problem. So you'll see I wrote the balanced chemical equation, and then I wrote the amount of oxygen and the amount of butane. Butane is C4H10. The amount of butane that I have underneath, so 125 of C4H10, 415 of O2. So when we do limiting reactant problems, there are a couple steps we need to follow. We need to, the first thing is you need to choose a reactant, and then you can convert that grams to moles. So in this problem, I chose butane, C4H10, 125 grams. We need to convert that to moles. We convert that to moles with the following T-chart. We want our grams to cancel, they go on the bottom, moles on top. Remember guys, you're going to get 2.15 for your answer. Plug your values in. Where do you look to find the mass? And remember, when you find that mass, it's always 1 mole. So you'll have 1 mole on top and then the mass on the bottom. After you find your moles, the next thing you do is you're going to convert the moles of what you found to the moles of reactant 2. So in this problem, that got a little white out. So 2.15 moles of C4H10. And then we need to use our mole ratio. Remember, we used the balanced coefficients. So then we plug in our moles of C4H10 on the bottom, so they cancel moles of O2 on the top. And look at the coefficients. Remember, the coefficients tell you the number of moles. So you're going to have 10 moles of O2, and you're going to have 2 moles of C4H10. When you solve, you have 13.975 moles of O2. Once you have your moles of O2, we can now convert to grams. So we take our moles and we just do a mole to gram conversion. Moles are on the bottom to cancel, grams are on top. Remember, use your periodic table to find the mass. Remember, you have the mass of 2 oxygens, not just 1. That does not change the amount of moles, though. Remember, guys, oxygen is diatomic. That's why there's always 2 of them. After you solve, you'll get a mass. So this mass tells us that we need 447.17 grams of oxygen to react with the 125 grams of C4H10. So in step 4, what you need to do is compare. Compare how much you need, or how much you actually need, to how much you have. If the number is larger, then it's the limiting reactant. If the number is smaller, then it's the excess reactant. In this case, 447 is larger than 415. Just forgot my unit. So then that means O2 is the limiting reactant. In part B is asking us what is the mass of each product that can be formed, how many grams of each. So that would be step 5. Step 5 is using the mole ratio to calculate the number of grams. You have to use, so really, really important, you have to use the moles of the limiting reactant when you are doing this conversion. You have to use the limiting reactant because the limiting reactant is going to stop the reaction. Once your 13.975 moles of O2 are used up, you're not going to be able to create anything else because you're going to be out of O2. So that is why you have to use O2 when you're doing this, the limiting reactant, which happens to be O2 when you're doing this conversion. So again, we start out with a mole conversion. These are just your mole ratio steps. So you're going to plug in your coefficients in the reaction. So you have 8 carbon dioxides, 13 oxygens. Remember guys, it asks you to do it for each product, so that's why I'm doing it for H2O at the same time. So again, we want our oxygens to cancel, bottom, then our moles of O2 will go on top. Again, plug your coefficients in. This will calculate moles of CO2 for you and moles of H2O. Once you are in moles, you can then use a mole conversion to calculate grams. Remember, if we want our moles of CO2 to cancel, moles of CO2 will be on the bottom. We want our moles of H2O to cancel, moles of H2O are on the bottom. And then grams are on the top because that's what we're converting to. Remember guys, grams are found on the periodic table. When you find the grams, they are always 1 mole. When you solve, you should find that you have 378.48 grams of carbon dioxide and that you have 193.66 grams of water. Base all of the questions off, 2 and 3, off of these steps. So the big difference between 1A and B, and 2 is that it's no longer broken up into 2 steps for you. So if you look at the problem, the first one you did 1 through 4 in part A, and then you did 5 in part B. This one doesn't break it up for you. So you're going to have to do steps 1 through 5 all in just the one part. Remember, do this on a separate piece of paper and label. It'll be easier to read. You won't have to like squeeze in your values. I hope everyone has a good day. Remember, if you have any questions, circle them and let me know.